In this video, we will discuss about functional groups in carbon compounds. There are large number of carbon compounds in the world and day by day their number is increasing. But every group of organic compound have a characteristic properties, and these characteristic properties of organic compounds is due to their functional groups. Many types of carbon compounds are formed by formation of bonds of carbon with each other elements such as halogens, oxygen, nitrogen, sulfur, etc. The atoms of these elements substitute one or more hydrogen atoms in the hydrocarbon chain and tetravalency of carbon is satisfied. As we know that hydrocarbons are mainly consists of carbon and hydrogen. So in these hydrocarbons, the hydrogen atom is replaced by halogens, oxygen atom, nitrogen or sulfur, and therefore a new class of organic compound is formed. The characteristics which are possessed by these organic compounds are due to the atoms which have substituted the hydrogen. The atoms of the elements which is a substitute for hydrogen is called as heteroatom. Sometimes heteroatoms are not alone but exists in the form of certain groups of atoms. In simple words, we can say that the functional group may be a single atom or it may be a group of atoms. The examples of heteroatoms are halogens, means chlorine, bromine, iodine and fluorine, oxygen, nitrogen, sulfur, etc. Now we will learn about the functional groups. In this section, we will try to understand the definition of functional group, and as well as we will be able to identify the functional groups in the organic compounds. Now as we know that the functional group is due to the heteroatom, and heteroatom is nothing but it is that atom or group of atom which replaces the hydrogen atom in a hydrocarbon. So the simple definition of functional group is an atom or group of atoms present in the molecule which determines the chemical properties or characteristics of organic compounds is called as functional group. Heteroatoms or the group of atoms containing heteroatoms forms a functional group. In this table, the class of organic compounds, functional group and their general formula is indicated. For example, a class is haloalkanes. In haloalkanes, the functional group is halide, which is indicated by X. These halide group may be fluorine, chlorine, bromine and iodine, and which replaces the hydrogen atom in the alkane. So therefore, the general formula of haloalkanes is Rx. In this case, the functional group is X, that means halide group. In case of alcohols, the functional group is OH, which is called as a hydroxyl group. The general formula of alcohols is ROH. Here R is alkyl group while OH is a functional group, that is the hydroxyl group. In aldehydes, the functional group is aldehydic group, which is nothing but it is a CHO group. In carboxylic acids, the functional group is carboxylic group, that is COOH. In ketones, the functional group is keto, and in ethers, the functional group is ethereal linkage. From all these examples, now we can say that in all these examples, R group is common. That means alkyl group is common, but there is a one atom or a group of atom which gives the chemical properties or the characteristic to these organic compounds, and these groups or atom are called as functional group. Functional group plays a vital role in determining the properties of organic compounds. In other words, we can say that the chemical properties of the organic compounds are determined by the functional group present in them. Homologous series. The meaning of homo is same. So the homologous series can be defined as a group of organic compounds which have the same general formula with the same functional group and showing more or less similar trends in their properties is called as homologous series. Homologous series of alkanes contains the members starts from alkanes to from methane to onward. The homologous series of alkane will contain methane, ethane, propane, butane, pentane, hexane, septane, octane, nonane, decane, and onwards. The homologous series of alkanes which have a general formula CnH2n plus 2 can be represented as follows. In this table, you can see that number of carbon atoms, general formula, and common name. When the number of carbon atom is 1, the general formula becomes methane and the common name is methane. So from methane to decane, all these members they can be derived by using a formula CnH2n plus 2. That means they have the same general formula and they will have the same functional group, as well as they will show more or less similar trends in their properties. That's why it is called as a homologous series. In another table, we are going to discuss about the homologous series of alcohols. Alcohols are a homologous series of organic compounds having general formula CnH2n plus 1 OH and their name is ending with OL. Here you can see the 6 members of the alcohol, that is methanol, ethanol, propanol, butanol, pentanol and hexanol. Now these 6 members they can be derived by using their general formula, that is CnH2n plus 1 OH. Means they have the same general formula, they have same functional group, that is OH, that means hydroxyl group, and they will show more or less similar trends in their properties. So that's why this is a example of homologous series. Similarly, you can make the homologous series of alkenes, alkynes, aldehydes, as well as ethers, and so on. Characteristics of homologous series. In this section, we are going to study or learn about the characteristics of the homologous series. Each member of the homologous series can be represented by the same general molecular formula. In this video, you have seen that the general formula of alkane series is CnH2n plus 2. That means every member from alkane to decane and onwards, they will have the same general molecular formula, that means CnH2n plus 2. All the members of the series have the same functional group. For example, in homologous series of alcohol, all the members was having the same functional group, that is hydroxyl group. Third property, all the members of the homologous series show similarities in their chemical properties due to the same functional group, because every member of a homologous series has the same functional group, and that's why they will have a similarity in their chemical properties. Two adjacent members of the series differ by only one methylene unit means CH2 unit. For example, we will take the example of two adjacent members of alkane series, methane and ethane. Methane has molecular formula CH4 and ethane has molecular formula C2H6. These two adjacent members, they differs by a CH2 unit. The next property is molecular weight of two adjacent members differs by 14. Now as we know that the two adjacent members, they differs by only one methylene unit, so therefore when we will calculate the molecular mass of this methylene unit, you will find that carbon has atomic mass 14 and two hydrogen atoms will have atomic mass 2. That's why 12 plus 2 14. That means the molecular weight of two adjacent members differs by 14. While going in an increasing order in any homologous series, there is a variation in their physical properties. Means whenever in a homologous series we will go from top to bottom, there is a variation in the physical properties due to increasing in molecular mass. In the last part of this video, we will discuss about nomenclature system of carbon compounds. Now the question arises, why there is a need for the nomenclature of carbon compounds? Because today near about 10 lakh carbon compounds are known to human being, and that's why there is a need for their systematic nomenclature. Initially, carbon compounds was named from their sources. The names of the alkanes thereafter were given from number of carbon atoms in them. This system was known as common system. But later, the number of carbon compounds became very large in number and their common names caused confusion. A need was felt to have a logic system acceptable to all for naming the carbon compounds. Generally, two systems are used to name organic compounds. Number one, common system, and number two, IUPAC system. In the next video, we will discuss about the IUPAC nomenclature system, where we will discuss the rules and how the organic compounds are named according to the IUPAC system.